Okay, this is Pre-Calc, section 5.2, proving trigonometric identities. When we prove something, we are trying to get one side to look like the other side. And there's some steps that usually help us when we get ready to do this. Sometimes we need all of them, sometimes we don't. The first one seems really bizarre, but you always want to choose the side that looks more complicated to work with. This could be higher exponent, it could be more terms on that side, maybe there's more trig functions on one side, but you always want to pick the one that looks the hardest. And then in step 2, if you have terms, you want to get a common denominator and try and simplify those. You might have to do some work beforehand to get that, like converting all of your trig functions. And then we want to substitute into our expression and use any of our identities that we've learned up to this point. Everything is fair game. Okay, so I'm going to start us off with a prove. So proving again means I'm going to make one side look like the other. So our first problem, we're going to actually do an algebraic proof. This proof can actually be worked with either side because your algebra skills are really good. You should know how to make one side look like the other. But according to our rules, I'm going to pick the side that looks the hardest. So to me, there's 3 terms on the right side, so I'm going to work with the right-hand side. If you want to work with the left-hand side, that's fine. So on the right-hand side, I'm going to start by taking out a GCF. So I notice that all of these have a 2 in them. So I'm going to start by taking out a 2 from my GCF. Once I have that, I have x squared minus 4x plus 4 left over. After every step, get into the habit of pausing, taking a breath, and looking at the other side of the problem. The other side of the problem shows a GCF of 2 out front. I have a GCF of 2 out front. So that 2 is staying put. I'm not moving it. Somehow I need to convert this trinomial into a binomial quantity squared. And you probably recognize right away that x squared minus 4x plus 4 is a perfect square trinomial. And that, of course, factors to 2 times the quantity x minus 2 quantity squared. Now the left side looks like the right side, so I am done. So that was our first proof. The algebraic ones are usually a little bit easier for us. Okay, here's our second one. For our second proving problem, we're just going to make the left side look like the right side. And again, either one of these sides would be pretty easy to work with, but technically the left side is a little bit harder because of the addition. It's got 2 terms instead of 1. And there are a couple of different ways that you can attack this problem. So I'm going to show you one of the ways, but that does not mean this is the only way. So I'm going to work on the left-hand side, and I didn't mention this in the last proof, but the equal sign actually plays a key role in here. So you're going to want to bring your equal sign down the entire time. So the first thing that I did is I changed tangent x into 1 over cotangent x using the reciprocal property. Again, pause, take a breath, look at the other side. I don't really see how I can get a secant x and a cosecant x just yet, but I'm going to keep working. Now you'll notice the parenthesis is on this side of the problem, and I'm working on the left side, so everything I do is going to stay on the left side of the equal sign. It's really important. Okay, so keep moving along here. Somehow I need to get the 1 over cotangent x plus cotangent x to look like the right-hand side. Well, anytime we have fractions and we want to add them together, we can get a common denominator. So I just multiplied the top and bottom over here by cotangent x to get common denominators. So up here we have cotangent x times cotangent x. That's how we got cotangent squared x. Now that my denominators are the same, I can write it as one giant fraction. Now I am running out of room on my screen. So when this happens, or you run out of room on your paper, what you want to do is draw an arrow directing your person, whoever's reading it or wherever you're writing it, onto your next step so they can keep track of it. This is really important too. Otherwise, I have no idea where you're going. Okay, so I believe 1 plus cotangent squared x might look familiar if you get your identities out from the other day. Hopefully you'll notice that that is the same thing as secant squared x. So that's just one of our Pythagorean identities. Pausing, taking a breath, looking at the right-hand side. The right-hand side, I need a secant x and a cosecant x. Well, currently I have cosecant squared x in the numerator, so I have that part hidden inside of that part. So somehow I need to figure out how to get rid of the other cosecant squared x and then how to get rid of that cotangent x. Again, I want to stress here that there are a bunch of different ways that you can attack this problem. So the next way that I'm going to do that, I'm actually going to write another side step up here that I didn't write in the problem. I'm going to factor out our numerator. And so I'm going to have cosecant squared x times 1 over cotangent x so that I can use my reciprocal rules. So I'm going to actually flip this guy right here using the reciprocal rule, and I'm going to use the reciprocal rule on this part too. So when I do that, I end up with tangent x over sine squared x. Now that might not be a comfortable move for you, but you're just going to have to get used to practicing them and get an eraser. Okay, continuing on then. Again, I'm pausing and taking a breath. I'm always trying to keep my eye on the prize here, which is secant x and cosecant x. And I'm not really seeing cosecant x or secant x, and now I've eliminated my cosecant x. So what I'm going to do here, maybe I should try this, is let's try tangent x and use the quotient rule on that. So I'm going to take tangent x and change it to sine x over cosine x. And again, you'll notice my parenthesis, or not, excuse me, not my parenthesis, my equal sign is still on the right-hand side of the problem. Pause and take a breath. Do you see where cosecant x and secant x are going to go? Well, on this particular problem, we can just flip and multiply our fraction. So I actually just pulled it apart here. So I took the numerator out and then did 1 over the denominator. Okay, pause and take a breath. Can you see where we're going to get secant x and cosecant x yet? Well, since this is a multiply problem, I can technically multiply straight across here. And you should be able to see that sine x will cancel out with sine squared x. So now I'm left with 1 over cosine x times 1 over sine x. And you can use your, okay, so pause again, sorry, pause. Look at your right-hand side of your problem. I need to get a secant x and a cosecant x. And from here it's pretty obvious because we can just use the reciprocal rules. So using the reciprocal rule here and the reciprocal rule here, we should end up with secant x, cosecant x. And again, the equal sign is on the right-hand side, so I have followed my problem, whoops, sorry, all the way around. Forgot to draw my arrow there. So we are getting the right-hand side of our problem.